Okay, 25 is
f of x equals x parentheses x minus 4 parentheses cubed.
okay, and it says that one day I'll be ready for class.
Yeah, but it don't say it goes.
All right. Okay, I want to know the points of inflection, which means I want to do what?
Find the second derivative
Get
and
this-
set it equal to 0.
Bingo.
I just can't do that. 'Cause I never
All right.
did it.
Well, what do we have here? We have
We have a chain rule. I still have
no. Well, we have a chain rule. We have a product rule. I tell you what. Y'all weren't supposed to come back with that one. Never mind. Let's just product rule may be quicker. F prime of x equals first term times the derivative of the second term times 1, right? Plus the derivative of the first term times the second term. Okay? Do y'all agree with that?
Yes, sir.
All right. So, what I'm about to write on that. What I'm going to do here is I'm going to factor out an x minus 4 squared. This is a binomial. I'm going to factor out an x minus 4 squared from both parts of it. So f prime of x is x minus 4 squared. And I'm left with a 3x here and an x minus 4 here. Are y'all good with that? The textbook I used before this year had more problems that dealt with this than this one has, so that's the reason I think I was asking if y'all had any questions about what I did here. Alright, so f prime of x is going to be, let's make this, this will be 4x minus 4, right?
Yes.
And then this will be, let's make this x squared minus 8x plus 16. I know that's scorched in there. Alright, now I'm going to multiply these two together. So I get 4x cubed. And then I will have minus 4x squared and minus 32x squared, so that's minus 36x squared.
This is still just f prime.
This is still f prime, yeah. Alright, or my x terms, I'm going to have positive 32x, and then 64, so 64 plus 32 is 96, right? And then 16 times 4 again is 64.
What is inside of the parentheses on second to last?
This is x squared minus 8x plus 16. Are we okay with this? All right. Let's take the derivative of this. I'll tell you what I'm going to do first. I'm going to factor out a 4 from everything. So this is going to be 4 times x cubed minus 9x squared plus, that's going to be 24x minus 16. Okay, so f prime of x, this is a constant multiplier rule, which means the derivative of it will be the constant times the derivative of what I have here. So it's 4 times 3x squared, then what? Minus 18x plus 24, right? Okay. Now from here I can factor out a 3. So f double prime of x is 12 times x squared minus 6x plus 8.
Mr. Ray,
Yes.
did you have to work all of those steps in the
No. I wanted to turn my first derivative into a polynomial. Because I love me some power rule. Yes.
How do you get from the second step to the third step?
From here to here?
Yeah.
Alright, that's what I'd asked about earlier. You've got a binomial here. Both of the parts of the binomial have an x minus 4 squared in it. So I factored out the x minus 4 squared from both parts. So I was left with the 3x here, and I had one more factor of x minus 4 here. Just a second.
Okay.
Alright, go ahead.
Couldn't you have just multiplied the 3 and the x in the first line of f prime with x and then done an addition with for the second derivative?
You would have had a product here.
I mean, yeah, like done the derivative of the first part, which would have been the chain rule, and then add that to the derivative of the second part.
Which is also a chain rule, right?
Yeah.
That would work. You tried taking the fun out of it, though. You gotta want it. Alright. Let's keep rolling. So this becomes 12 times. That's right, x minus 2 times x minus 4. And we want to set that equal to 0. Very good. So x equals 2, x equals 4. Put those on the number line. Right? Okay, what's a number to the left of 2? Even easier to work with? 0. All right. What's the number between 2 and 4?
3.
And between 4 and infinity? 5. All right. Now, if we're talking about points of inflection, where am I interested in plugging it in? Second derivative. Plug it into the second derivative. Now, yes, you can plug it into this step right here, and it makes it a little quicker. All right, if I plug in 0, this is always positive, so I have a negative times a negative, which is positive. So it's concave up. No, it's concave up. First derivative is where you see if it's increasing or decreasing. All right. 3. 3 right here is, and 3 right here is negative times positive. All right. 5. Positive, positive. Good stuff. Concave up. No. It's no. All right. So we're going from concave up to concave down to concave up. Intervals of concave up would be beautiful.
I feel like you didn't have to dig that shirt.
What now?
He called you tacky, you went
No, that's not what I did.
He said you tacky.
Why are you trying to start? You get that?
So sad.
We just joke with you, Mr. Murray. Well, not me. I didn't say anything. Don't feel bad. She got the extra.
All right.
Me too, back to
Hold on just a second. Y'all are going to make me laugh up here. Let's get back to calculus for just a second at least.
concavity down is 2 to 4.
Very good. All right. Thank you for getting back on topic for me. Even asked, I've forgotten what question I had to ask next. Okay. All right. So everybody okay with that?
Yes.
Okay. Again, it's second derivative. What are my points of inflection?
You put the point that you got, the x's, into the first original.
The first original is opposed to the second original. Yes, that is correct.
The first.
Oh, I say that all the time too. So all right. So this would be 2 times, and then 2 minus 4 is negative 2. So it's 2 times.
8. No, negative 8.
It's gonna be so it's negative 16. So I have the point 2, negative 16.
Yeah.
Plug in 4. It's 4, 0, right? Because you'd have 0 cubed.
Yeah.
Okay, 4, 0. So those are your 2 points of inflection. Oh, that didn't. All right.